Right, the next thing to look at as far as chemistry and materials is physical properties versus chemical properties and physical change versus chemical change. So we're going to look first at physical properties. So physical properties are anything that describes the look or the feel of a substance. So if you think about, materials, how would you describe a material is basically what we're looking at here. And so you can see down here some different examples. So we can do things like opacity. So basically, is it opaque? Can you see through it or not? So it's opaque if it's something like gold where we can't see through it, or it's transparent if you can, or semi-transparent if you can sort of see through it. So we're also looking at things like color, the phase that it's at any given temperature. So here, these are the phases at 25 degrees Celsius. If we look at the phase at 0 degrees Celsius, that phase would change. So for example, at 0 degrees Celsius, the phase for water would change to solid. And then we can also look at things like density. So how close are the molecules to each other? Because that's what density is describing. So the higher this number is, the closer those molecules or atoms are to each other. You can also look at things like hardness. So for example, diamonds are basically considered the hardest mineral. You've probably heard that. You can use diamonds to basically scratch anything. We use them for drills and things like that. So we can also look at the texture. So how does it feel? Things like that. So any sort of thing that we can use to describe the look or feel of a substance. And we often forget about things like phases and so forth. The thing is with physical properties, they're tied to physical changes. So a physical change is what happens when the conditions change, but the substance is still the same substance. So, for example, a physical change would be dropping the temperature of the water until it becomes ice. But if we stop changing the temperature, the water will return to water. But either way, whether it's solid or liquid, it's still the same substance. It's still made out of water molecules. So physical properties describe those looks and feels of the substance, and the physical change is tied to those properties. And so the physical properties can change, but it's still the same substance. So same thing like with gold. You can heat gold, it will melt, but it's still gold. This is different from chemical properties. So chemical properties describe the tendency of substances to transform into new substances. So basically this is talking about how likely it is a substance will react with something else. So for example, we've got a couple of them here. Here you're looking at a burner. So we've got methane or propane, and it's talking about the chemical property that if you react methane with oxygen, it can form carbon dioxide and water, giving off heat. This one, many of you have probably done this one before. Baking soda. Baking soda will react with something like vinegar to form other materials, carbon dioxide and water. In this case, absorbing heat. So these are chemical properties. So they talk about what they might react with and how that reaction would occur. Last one, many of you have, I'm sure, seen copper statues that look like this green patina. The green patina is the copper reacting with carbon dioxide, not oxygen, but carbon dioxide and water to form that green-blue patina substance. Many people think it's the oxygen, but it's actually the carbon dioxide and water that's actually creating that reaction. All right, so then how is this related to chemical change? Well, chemical change is the result of two or more substances in a chemical reaction. So, for example, here what we're looking at is methane and oxygen, so that one with the burner. So we've got methane, carbon with hydrogens attached to it, and oxygen molecules. They undergo a reaction, so whenever we see this arrow, it's talking about a reaction, which means that the atoms rearrange themselves, so they pop apart and rearrange themselves, and in this case we end up with water and carbon dioxide. So we get new substances, so that's how we know it's a chemical change. The substances are new because of a rearrangement of atoms. And the new substances will have different physical properties and different chemical properties than the originals. So, for example, oxygen is a gas, just like carbon dioxide. However, as you probably are quite aware, oxygen is the one that we need to breathe in order to use in our reactions in our body. Carbon dioxide is a waste product for us. We can't use this one, we breathe that one out. And then water is a very different material from methane. You can't catch water on fire. So very different substances at the end of a chemical change. So then the question is, how do you tell if a change is a physical change or a chemical change? Because it can be difficult because both of them do cause changes in their physical appearance of the material, right? So, for example, if you're melting gold, right? Yeah, it still kind of looks like gold, but it's changed the physical appearance of the gold. Now that one's a little easier because we generally know it's still gold, but if you're not as familiar with the substance, how do you know if it's a physical change? And the big clue is that physical changes can be undone by restoring the original conditions. So if you're changing the temperature, stop changing the temperature. If you're changing the pH, stop changing the pH. If you're exposing it to another chemical, stop exposing it to another chemical. If you do whatever the if you stop changing the conditions and it reverts to its original state, you know it's a physical change. Now, an exception to this would be something, for example, like cutting hair. So you're not going to be able to restore the hair to its original state, right? If I took a pair of scissors and cut my hair off, I can't put my hair back. But my hair is still, the hair that was cut off is still hair. So that is actually a physical change and not a chemical one, because it's still hair. So if you're just cutting it, you know, altering its shape in that way, then it's a physical change. And chemical changes won't do this. So if you stop whatever it is you're doing to the material, chemical changes will not revert. So for example, the car that's here in the picture, you've probably seen cars like this. You may have a car that has this condition in it. This has rust, iron oxide. And iron oxide is not something you can undo. It's a chemical change. Now, can you remove it? Yes, but you're actually going to physically remove the material. So you cannot undo the damage to that material. You're going to have to physically remove molecules from it in order to remove the rust. So you can't unrust the car so that those molecules still stay there. So let's take a look at an example of a chemical versus a physical change. So these two test tubes contain a chemical, well, two different chemicals. So you can see here at the beginning what they look like. So the top one starts out red, the bottom one starts out yellow, and then this little guy down here, it's hard to see the flame, but this is a Bunsen burner. So heat is applied to both test tubes, and then they're allowed to cool off. So the heat is turned off right after this picture. So there's no heat here. And so the question is, which one of these is the physical change and which one is the chemical change? And if you said the bottom one is the chemical change, you're correct, because it started off yellow, it changed to a different color, but then when the heat was turned off, it turned back to its yellow color. Versus the one on the top that started off red, it changed color and then started making this new stuff in the test tube and then turned black. That shows that it has made a new substance, a new material, and it doesn't turn back to the red substance either. So this top one is a chemical change. All right, that is the end of the physical and chemical changes. The next section of lectures is going to talk about chemical bonds, how we put atoms together.